The Tower of Babel, the Pyramids of Giza, and the Three Gorges Dam all represent mankind's mammoth ambition to create massive structures. The penchant for constructing large structures can be traced to various socio-cultural, psychological, and economic factors that have evolved over millennia. We delve into some of these factors. Symbolism and cultural importance. Constructing large structures often serves as a way to embody cultural ideals or convey symbolic messages. For instance, the Great Pyramid of Giza was not just a tomb. It was a testament to the pharaoh's divine status and the society's technological prowess. The symbolism of large structures frequently contributes to their cultural value, making them focal points for societal cohesion. Technological demonstration. Building large structures often requires a high level of architectural and engineering skill. The construction of such edifices has historically been a testament to a society's technological advancement. Modern examples like the Burj Khalifa in Dubai showcase advancements in engineering and material science. This appeal to technological mastery partly explains why nations continue to invest in ambitious construction projects. Economic benefits. Large structures like skyscrapers and massive stadiums often become commercial hubs or tourist attractions, generating revenue. For example, the Sydney Opera House contributes significantly to Australia's economy by attracting tourists. Similarly, airports and seaports act as commercial hubs that facilitate trade and commerce. Political capital. Leaders often commission large structures to garner political support or to assert their legacy. The construction of Versailles by Louis XIV served both as a symbol of France's preeminence and as a way to consolidate power by keeping the nobility close. Psychological factors. From a psychological standpoint, big structures could be interpreted through the lens of evolutionary psychology as a form of extended phenotype, showcasing the capabilities of a particular group much like a peacock's feathers display fitness. Where does this end? The limits of such construction are determined by a multitude of factors including technological advancements, economic feasibility, and societal values. Environmental sustainability is increasingly becoming a constraint, prompting new designs that aim to minimize ecological impact. It's worth noting that the continued trend of constructing large structures will depend on advances in sustainable architecture and construction technologies. As our understanding of sustainability improves and as societal values evolve, the nature of these constructions may change, but the underlying impulses driving them are likely to endure. We now examine 10 of the biggest structures ever built, highlighting the motivations for each, the complexities involved in their construction, and their lasting impact on society. 1. The Great Pyramid of Giza. The Great Pyramid was constructed around 2613 to 2577 BCE, during the reign of Pharaoh Khufu. It served as a tomb and was symbolic of the pharaoh's divine status. The pyramid was also a monumental testament to the Egyptian civilization's achievements, spiritual beliefs, and technological prowess. The construction required precise architectural planning and an acute understanding of geometry. Advanced technologies for the time, such as levers and possibly even rudimentary cranes, were utilized to move limestone blocks weighing several tons. The exact costs are hard to quantify in modern terms, but it required a large workforce, possibly in the tens of thousands, over about 20 years. Most were likely skilled laborers rather than slaves, contrary to popular belief. Challenges included logistical issues like transporting massive stones and providing for the large workforce. The Great Pyramid remained the tallest man-made structure for thousands of years and symbolized Egypt's cultural and technological zenith. It remains an archaeological enigma and a focal point of global tourism. Fun fact: the Great Pyramid was originally encased in smooth, white Tura limestone, which reflected the sun's light, making it shine like a gem during the day. This earned it the name, Horizon of Khufu, in ancient times. Later pharaohs repurposed the limestone for other projects. 2. The Great Wall of China. Beginning from the 7th century BC, various sections of walls were constructed, some of which were later linked by Qin Shi Huang, China's inaugural emperor, 220 to 206 BC. However, scant remains of the Qin Wall exist today. Over time, many succeeding dynasties erected and preserved numerous segments of these border walls. The most renowned parts of the wall were established during the Ming Dynasty era, 1368 to 1644. It was primarily designed for defense against invasions from the north, particularly from Mongol tribes. It also acted as a symbol of the strength and capability of the ruling dynasty. The Great Wall is not a single wall but a network of walls and fortifications. Materials varied based on regional availability, from tamped earth to bricks and stone. The sheer length of the wall required extraordinary logistical coordination. The human and economic costs were monumental, with estimates suggesting that hundreds of thousands, if not millions, of laborers died during its construction. Challenges included the harsh climate, difficult terrain, and the enormous manpower required. The wall had mixed success in preventing invasions but became a symbol of China's historical and cultural heritage. Today, it is one of the most recognizable structures in the world and a significant tourist attraction. Fun fact: it is the longest man-made structure in the world, with an official length of 21,196.18 kilometers, 13,170.7 miles, approximately half the length of the equator, and can be seen from space. 3. The Colosseum, Rome. Built between AD 70–80, the Colosseum was designed to serve as an amphitheater for public spectacles like gladiator contests, animal hunts, and mock sea battles. Commissioned by Emperor Vespasian, the Colosseum was an ostentatious demonstration of Roman engineering and a political tool to gain popular favor through entertainment, bread and circuses. Built primarily of concrete and sand, the Colosseum was a feat of Roman engineering, showcasing the innovative use of arches, a technology that allowed the distribution of weight and increased structural stability. It could hold up to 80,000 spectators and featured intricate mechanisms, like trapdoors and lifts, to add dramatic effects to performances. The cost was largely borne by the spoils of the Jewish temple after the siege of Jerusalem in AD 70. The Colosseum was built in just 10 years, a remarkable feat but one that came at the cost of using slave labor for much of the construction. After its completion, the Colosseum became a central social and cultural hub in ancient Rome. Its decline came with the fall of the Roman Empire, but its legacy influenced modern stadium designs. Currently, it serves as an iconic tourist destination and a poignant reminder of both the grandeur and the moral complexities of ancient Rome. Fun fact: the Colosseum could be filled with water to stage mock naval battles known as naumachia. The mechanics of how this was achieved without damaging the structure remains a mystery. 4. Hagia Sophia, Istanbul. Constructed between AD 537 during the reign of Byzantine Emperor Justinian I, Hagia Sophia was designed as a Christian basilica to replace an earlier church destroyed by riots. It was intended to demonstrate the wealth and artistic skill of the Byzantine Empire, as well as to serve as a place of Christian worship. The Hagia Sophia is renowned for its massive central dome, which was revolutionary in its time. Built with specially formulated concrete, the construction involved mastering complex mathematics and engineering, including the skillful use of pendentives, a triangular segment that allows a circular dome to be placed over a square room. The costs were enormous, nearly bankrupting the empire. The initial dome collapsed due to an earthquake in AD 558, necessitating extensive repairs. The project demanded high-quality materials, including marbles and decorative stones from across the empire, and a vast workforce. The Hagia Sophia served as an Eastern Orthodox cathedral for almost a millennium before becoming an Ottoman mosque, and then, a museum. Its architectural innovations influenced both Western and Eastern church designs for centuries. Today, it's a UNESCO World Heritage Site and a symbol of the complex relationship between different cultures and religions. Fun fact: the main dome of the Hagia Sophia collapsed twice due to earthquakes and was rebuilt. Each rebuild led to changes in its design, contributing to its unique architectural history. 5. Panama Canal. The Panama Canal, completed in 1914, was motivated by the economic and strategic interests of enabling quicker maritime passage between the Atlantic and Pacific Oceans. The United States, which took over the project from the French, viewed it as essential for both commercial trade and military mobility. This megastructure required the removal of approximately 268 million cubic yards of earth. Engineers had to solve multiple challenges, including the construction of a series of locks and gates, to elevate ships from sea level to the height of Gatun Lake and then lower them back down. The project cost the United States about $375 million at the time, an enormous sum. More significantly, it cost a large number of lives, particularly due to diseases like malaria and yellow fever, which affected the workforce until medical interventions improved conditions. The Panama Canal revolutionized global trade routes, significantly shortening the maritime path between the east and west coasts of North America, and by extension, between the Atlantic and Pacific trade zones. It continues to serve as a critical conduit for global commerce. Fun fact: during its construction, the Panama Canal used enough dynamite to build a wall 9 feet high and 18 inches thick around the entire coast of the United States. That is a lot of explosives. 6. Hoover Dam. Completed in 1936, the Hoover Dam was constructed to control the Colorado River, provide irrigation, and produce hydroelectric power. It was also seen as a job-creating enterprise during the Great Depression. Built from 3.25 million cubic yards of concrete, the Hoover Dam was an engineering marvel of its time. It required innovative solutions like the use of cooling coils to ensure the proper curing of such a massive volume of concrete. The project cost approximately $49 million at the time, equivalent to about $700 million today when adjusted for inflation. The construction faced challenges including harsh working conditions, which led to the loss of over 100 lives, and technological complexities in dam design and construction. The creation and operation of the Hoover Dam resulted in significant alterations to the water usage and flow, deeply affecting the Colorado River Delta. The dam is considered a key factor in the degradation of this estuarine habitat. The Hoover Dam had profound impacts on the American Southwest, enabling large-scale irrigation and urban development. It also serves as a major source of renewable energy, though its environmental impact on local ecosystems has been the subject of ongoing debate. Fun fact: Hoover Dam created America's largest reservoir, Lake Mead, which covers about 248 square miles and is capable of holding 26.12 million acre-feet of water. 7. Burj Khalifa, Dubai. Completed in 2010, the Burj Khalifa serves multiple purposes. It's a commercial space, a luxury residence, and a symbol of Dubai's rapid economic development and ambition to be a global hub. The tower was constructed as a centerpiece to diversify Dubai's economy through tourism and international investment. The Burj Khalifa is the world's tallest building at 828 meters. Its construction required pioneering advancements in structural engineering, such as the use of a bundled tube design and advanced wind engineering tests. The project also implemented innovative construction techniques, such as the jump form system that sped up the building process. The construction required innovations in concrete mixes and pouring, air conditioning systems, multi-level water pumping stations, and water reclamation processes. Techniques which can all be used in future projects. The construction cost was approximately $1.5 billion. Challenges included the logistics of high-altitude construction, sourcing and managing a large international labor force, and implementing highly specialized construction technologies. Upon completion, the Burj Khalifa redefined the limits of skyscraper engineering and became a significant tourist attraction. However, it has been criticized for its vast energy consumption and the exploitation of labor during its construction. The concept of erecting a landmark structure and then surrounding it with other commercial properties proved to be an economic boon for the ancillary properties. But the Burj Khalifa itself generates little to no profit. Fun fact: the tip of the Burj Khalifa can be seen from up to 95 kilometers away, and the building sways a total of 1.5 meters in Dubai's strong winds. That's a bit scary. 8. International Space Station, ISS. Built collaboratively by multiple countries, including the United States, Russia, and members of the European Space Agency, The ISS serves as a microgravity lab for scientific research. Its construction represents the ambitions of humanity to explore and understand outer space. The ISS is an unprecedented marvel of aerospace engineering. Its construction involved assembling various modules in orbit, a feat requiring extremely precise maneuvers and the development of new assembly techniques to be executed in the microgravity of space. The ISS is one of the most expensive structures ever built, with estimates often exceeding $150 billion. Challenges included the complexities of international collaboration, the logistics of sending materials and astronauts to space, and the ongoing need for life support systems. The ISS has been instrumental in fostering international cooperation in space exploration. It serves as a platform for an array of experiments that benefit research in medicine, climate science, and materials engineering. However, its high costs and potential risks continue to be points of debate. Fun fact: the International Space Station travels at an average speed of 28,000 kilometers, about 17,500 miles, per hour, meaning it orbits Earth approximately every 90 minutes. 9. Large Hadron Collider, LHC, CERN. The LHC, completed in 2008, aims to unlock the secrets of the universe by colliding high-energy protons at close to the speed of light. The project seeks to answer fundamental questions about the nature of matter, energy, and the origins of the universe. The LHC is a 17-mile-long underground circular tunnel filled with superconducting magnets cooled to near absolute zero, 0 degrees Kelvin or minus 460 degrees Fahrenheit. It required advancements in particle physics, engineering, and computing, including the development of superconducting materials capable of withstanding extreme conditions. The LHC cost approximately $9 billion. Challenges included the coordination of a multinational team of scientists and engineers, the development of cutting-edge technologies, and the construction of a facility capable of safely managing extremely high-energy experiments. The LHC confirmed the existence of the Higgs field. The Higgs field enables the presence of matter and interactions as we recognize them, and also accounts for the manifestation of mass in all identified elementary particles. In the absence of the Higgs field, confirmed by the discovery of the Higgs boson particle, atomic elements, stars, and life would not exist in this universe. The facility has also driven advancements in various fields, from material science to computing. However, concerns have been raised about the high cost versus the tangible benefits of the research. Fun fact: the data collected by the LHC generates about 30 petabytes, 30,000 terabytes, of data annually, which is processed by a global computing grid spread across 42 countries. How is that for scale? 10. NEOM, Saudi Arabia still in the planning stages. NEOM is envisioned as a $500 billion smart city aimed at diversifying Saudi Arabia's economy away from oil. The project seeks to integrate cutting-edge technologies to create a model for future urban development. NEOM is planned to incorporate advanced infrastructure, including automated transportation, AI-driven governance systems, and sustainable energy solutions. It aims to be at the forefront of technological innovation, from robotics to biotechnology. With an estimated cost of $500 billion, NEOM is among the most expensive planned projects ever. The project faces numerous challenges, from the geopolitical to the technological. It could also raise ethical questions about labor rights and environmental impact. As NEOM is still in the planning stages, its impacts are yet to be seen. However, if realized, it promises to be a watershed in the field of smart cities, with implications for urban planning, technology integration, and sustainable development. Fun fact: the planned site for NEOM covers 26,500 square kilometers, an area bigger than the country of Slovenia, and is expected to be 33 times larger than New York City when completed. 33 New York cities. These examples demonstrate how megastructures have evolved to pursue increasingly complex and ambitious goals, from understanding the basic fabric of the universe to envisioning the cities of the future. Each project embodies a unique set of motivations, technological demands, and potential impacts, underlining the diversity and scale of human ingenuity. We hope you found this enlightening and thank you for watching.